All right, so I started the recording. Today we're going to start, I can't believe it, our final topic of the class. Isn't that crazy that we made it this far already?
Yeah,
Went fast.
It goes fast. It always does. It never seems like it does when like you're in the thick of it, but then, you know, once you get to the end, it's like, wow, it actually kind of did go fast. Yeah, so today what I want to do is I want to talk about hypothesis testing, an introduction to it. So just a few quick announcements real quick. Next Tuesday, 11/24, class is canceled. Okay, I won't be here. The college is open. You still have your other classes, but I just won't be here. It's Thanksgiving week. I always take the Tuesday off. Everybody okay with that?
Yep.
Yeah, that's fine.
Not that if you guys had said it wasn't fine, I wouldn't change it, but it's still off on Tuesday. So your week 12 assignment is actually, it's posted right now, is not due until Monday the 30th. So you have about 2 weeks to complete it, but this is important. You only have one attempt on the assignment. So let me talk about that real quick. Okay, so normally you know how you have two attempts.
Yep.
All right. If you go look at under week 12, all right, for our class. First off, let me just talk about what's in the folder. You'll see, or in the tab, you'll see that there's 4 folders here, okay? What I'm gonna do today is I'm gonna teach basically lectures 1 and lecture 2, okay? So if today's class was a little confusing, you can always go back and rewatch lectures 1 and 2 or the recording from class as a way to review. Additionally, there's just extra examples and different examples that I'm going to do in class and specifically in lecture 2. Lecture number 3 and 4 are new, that you can watch these on your own. I highly encourage you to watch lecture number 3 on the p-value approach. It's just this, I'm going to do the critical value approach to hypothesis testing, and that'll make sense in a little bit. But the p-value approach is a little bit easier and uses your calculator. So definitely watch that video. And then there's just an extra lecture here on, misspelled there, produces, on hypothesis testing, uses a website to do it. So you can watch that video as well. Okay, and you click on that. I have a video for that. Now your homework, your online quiz this week. So let me just show you what it looks like. So it's basically 2 questions, even though it lists 5. So question number 1, 2, 3, and 4 are all related to the same question, okay? And it just walks you through this hypothesis testing, okay? Step by step, okay? And you have to select, this will make more sense after we do the first example, okay? It's pretty easy. And then step number 5, I have to manually grade, or question number 5, all right? So in class today, what I'm gonna do is I'm gonna talk about something called a 5-step process for hypothesis testing. What you have to do here in question number 5 is you have to write out all the steps you have to do. So you write something like step 1, and then what you would get for step 1, okay? How you set up the test, and so on. And then you do the same thing for step 2, and you have to put down your solutions in here, okay? All right, and then what I'll have to do is I'll have to manually grade these over the week, all right? So that's your test, your week 12 assignment. So what I highly recommend you do, honestly, is, after class, sometime early in this week, rewatch the videos, look at the videos in lecture 3 and lecture 4, and then just get the assignment out of the way. And then that way you can enjoy Thanksgiving. Okay, don't have this hanging over your head while you're chowing down on food and watching football. That's basically what I'm gonna do. So I'm just assuming everybody else is doing that. That's kind of just this week. Does anybody have any questions about that? No questions? Is anybody looking forward to Thanksgiving? How about that one?
Oh yeah.
Sort of. We're conflicted about even having it now.
Oh, see, we're not getting together with the extended family, so it's like going to be the best Thanksgiving ever for me.
Oh my God.
It's the truth. I'm sorry. I'm just having my my mother-in-law and father-in-law. We usually do like a 30-person Thanksgiving at my in-laws every year. And this year it's just going to be myself, my wife, my son, and my mother-in-law and father-in-law. And like, we're just like incredibly excited about it. It's not going to be this chaotic thing. We're just going to cook here and take it easy. Because they're in our quarantine bubble, the mother and father. So we didn't want to break that. Not that, I don't know why I wanted to tell you guys that, but that's just what's going on in the Sokol household for Thanksgiving. But I don't know, even if it's just by yourself, you should do something nice, you know?
That does sound nice, a small Thanksgiving. Ours is usually 40.
Oh yeah, it's just stressful, right? Like, you got to make sure you say hi to everybody and a lot of small talk with people you see once a year. Just like, I don't know. Okay. Anyways, I'm just going to have football on all day. It's going to be glorious. Okay. For a class today, I have this PowerPoint here that I didn't post. There's not much in it, and I'm going to do a lot of writing. One thing you're going to need today during the second half of class is you're going to need your graphing calculator, just very briefly. So have that handy. And then during the second part of class, if you under lecture number 2, there's this thing called the T-table that we've talked about before. You've learned in your lectures. I have this handy. Okay, we're gonna use this a little bit at the second part of class. Okay. So, any other final questions or just comments before I get started? Okay, just a quick sip of coffee. All right, let's do this. So this is our last topic of the class. I always get excited when we get to this topic. It means the end is in sight. Okay. So over the next couple weeks, this is what's going to happen. This week and in the videos on your own, we're going to talk about this thing called hypothesis testing for a mean. When we come back on the after Thanksgiving, we're going to do hypothesis testing for a proportion. And then what we're going to do is we're going to have 1 week where we just come together and do a review for the final exam. And then the final exam is going to be on 12/15. All right. So I built in I have a extra week just for us to review for the final, so everyone can do really well on the final. I hope that's okay.
Thank you.
Yeah, I want everyone to do great. All right, so there's 2 words here, hypothesis and testing. First off, let's just, have you heard the word hypothesis before?
Yes.
Okay, what do you think, like, just generally, a hypothesis is?
If then because.
I mean, that's a logic statement. Yes, like you're trying to draw a conclusion about something, but yep. Anybody got another definition too?
It's an educated guess.
Sure, an educated guess. Sure. That you think is true. Yep. So in statistics, hypothesis has we use the term hypothesis a little bit differently. Okay, kind of like an educated guess. All right. But in statistics, a hypothesis is a statement regarding the characteristic, and by characteristic, I mean value, of a population parameter. All right, so and this will make more sense as soon as I do the first example. Okay, so I'm going to make a statement about the value, the characteristic, or the value of a population parameter. Okay, so it's been a while, so let's just make sure we understand exactly what a population parameter is. So if you look up here, I'm going to do hypothesis testing for two things, for a mean and a proportion. So does anybody remember what the Greek letter was for a mean?
mu.
Yeah. Okay. Awesome. So we're going to make some claim about the value of a population mean. Okay, some mu. And then we have a proportion. What letter do we use for proportion?
P.
Yep. So I'm going to make a claim about these two values. Okay. All right. And what our whole goal is in this section, we want to test this claim or this statement. All right. That's what hypothesis testing is. We want to test this statement. I'll explain, what exactly I mean by testing. Is everybody okay if I move on? I know I was going a little fast here. I want to give everyone a chance to copy it down if they need to. Plus, it gives me a chance to sip my coffee. You guys remember a few weeks ago when I tried to give up coffee? Anyone remember that?
Yeah.
I don't know why I ever thought I'd be that foolish.
What happened to the tea?
It just didn't wake me up. I needed a nap by like 9:30, so got to go back to the coffee. I hope you guys enjoy my banter, by the way. I don't know if your other professors do it, but just try to make your class a little less dry.
Oh my God, I have one class that is just super flat.
Okay, well, I try to have some dry humor in here. Okay.
Great, professor. You wake me up with your jokes.
Thank you. Even if that's not true, I appreciate it. I appreciate the comment. All right. All right. So exactly what is hypothesis testing? Okay. So it's a process to test the validity of a claim. Okay. So let me give just another formal definition. Okay. So hypothesis testing is a procedure. So what I'm going to teach you in class is this procedure. Okay, that's what we're going to do. We're going to learn the procedure for hypothesis testing. Okay, it's a procedure based on sample evidence. Right, used to test the statement or a statement regarding the characteristic or value of a population parameter. Okay, and this is going to be, so we're going to test the a statement regarding the characteristic of a value characteristic or value of a population parameter. And this is the first example we're actually going to do in class. Okay. So there was this recent study that said, on average, college students watch an average of 20 hours of television per week. So college students watch 20 hours of TV per week on average. So that's the average of all college students. And I know I have some other slides here, or other dots here, but when you hear that, do you think WCC students watch more or less TV than 20 hours per week on average?
Less.
Here's the thing. If you read next, so professor at WCC thinks the mean hours of TV watched per week by WCC students is less than 20 hours per week on average. So I'm just curious, why do you guys think it's less than 20 hours?
I guess because we don't watch that much TV nowadays.
No time. See, I think so. I think what Jessica's hinting at there in the chat is what I think. Like, so as a community college student, you probably are juggling a lot of things, right? Like maybe you have work, maybe you have a family life, and on top of that, you're trying to go to school. So there's just no time in the day. Okay, right. So do you kind of agree with maybe what Jessica's saying there in the chat?
Yeah.
Yeah, but like here's the thing also. Like people also watch more TV than they realize, okay? You know, like myself, for example, I'm like, oh, I don't watch 20 hours of TV a week. And then just like I was just thinking about like last week, like, you know, The Mandalorian came out on Disney Plus. I had to make sure to watch that. You know, my son yesterday fell asleep on me, so I got to watch an hour of TV. So all of a sudden it starts adding up. So maybe we watch more than 20 hours a week on average. I don't know, okay? So here's the thing. This is my hypothesis right here. Okay, I'm making a claim, okay? And my claim is that WCC students, the mean hours of TV watched per week by WCC students, okay, so I'm making a claim about the mean. Okay. And what I have to do now is we have to test this claim. So what we want to do is we want to see if the claim is correct. All right, and that's what we're going to do in class today. We're going to actually test this hypothesis, okay, to see if it's true or false. All right, so we know like my claim can either be correct or incorrect. So it could be true or false. So it could be correct or incorrect. Okay, we just can't say, oh yeah, you're right, Matt. You know, we need a method to do this. So we need a method to test that, and that's what we're going to learn today. All right, is everybody okay if I move on to the next slide?
Yes.
Okay. All right, so since a claim can be either true or false, right? Like, so my claim here that you watch less than 20 hours a week on average, or it can be true or false. Whenever we do hypothesis testing, okay, hypothesis testing is going to be based on two statements, okay, every time, all right? So you always need these two statements. The first statement is called the null hypothesis. Okay, the null hypothesis. And it's denoted as H with a subscripted 0, okay? And don't worry, let me get these definitions through, and sometimes it's confusing at the start, and I don't know if you guys agree with this, but like a lot of times in these classes, you know, I put some definitions up there and it's like, what is he kind of talking about? But then after you see the first example, it makes sense. Would you agree with that?
Yeah.
Yeah. So it's going to be the same way. So just go with me on this one. So the null hypothesis, denoted as H0, H with a subscript of 0, is a statement to be tested. Okay. The thing about the null hypothesis, what's going on is the null is assumed true. So you assume the null hypothesis is true until evidence suggests otherwise. Okay, so think of the null hypothesis as your starting assumption. Okay. The second statement we need to always set up is what's called the alternative hypothesis. And this is denoted as H with a subscripted 1, Okay, but some textbooks, and you might see it otherwise, some people show it as H with the subscripted A for alternative. I'm always going to show it as H1. Okay, so the null will be H0, the alternative will be H1. This is also a statement to be tested.
Professor, question: when we are doing the assignment, the last question, do we have to write these statements
Yeah,
as
so
step 1 and 2, right?
so what you'll see is after you see, let me just fast forward a second, then I'll come back to this. This is the first example we're going to do. And what I ask you to do is I write the steps out, and you'll see as we do the example what I want you to do. So like step 1, you'll see in a couple minutes will be set up the test and then what you're going to have to put into the problem. Step 2 is going to be select the level of significance, and then I'll show you what you do there, okay?
Got it. Thank you.
Yep. Okay, so this is also a statement to be tested. The thing about the alternative hypothesis is we are looking for evidence. To support the alternative. Okay, so we start with some assumption. All right, that's our null hypothesis. And then we're looking for evidence to support some other claim, which we call the alternative. So like, what the heck? Like, what do you mean by this, Matt? Okay, like what's a null and what's an alternative hypothesis? So believe it or not, you all know of a hypothesis statement in the real world. You just never thought about it in these terms before, okay? And here's an example from the criminal justice system. Okay. Suppose, just for fun, just as like an example, suppose I'm arrested, okay, for like embezzlement, okay? Suppose I'm just arrested, okay, and I go to trial, okay? What is the jury instructed to do generally in a criminal trial? What assumption do they start with in the criminal justice system if you're on trial?
Innocence
Innocent until what?
Until proven
until
guilty.
proven guilty.
Okay, so it's actually a hypothesis statement, okay? They start with the assumption that Matt, myself, is innocent, okay? That's the null hypothesis. So we're starting with you're innocent. And what the alternative is what the district attorney or the prosecuting attorney is looking to show is they're looking to show evidence to say, no, Matt's guilty, he did it. So this is how we're gonna write our hypothesis statements. We're gonna write two statements, one on top of each other, okay? So here's the null, and here's the alternative. Okay. So the null statement, you know, what in this example is that the defendant is innocent, because you have to have some like starting assumption. And what we're looking to show evidence, so let me just say starting assumption. Uh-oh, do you guys hear the little guy going?
Yes.
Yeah.
Not happy.
It's nap time, so he hates nap time every day.
I wish we still napped.
There's just not enough time in the day to nap, you know. It's sad. So the alternative is the defendant is guilty. Okay, and this is what you're looking for evidence to show. Okay. So here's the thing, and this is really like a subtle introduction to the next topic. When somebody, say I go on trial, okay, for that embezzlement case, All right, and the district attorney doesn't show that I'm guilty. Does the jury say I'm innocent, or do they say something else? Like when you go on trial for a crime, the jury doesn't say, "Oh, Matt, you're innocent." They say that you're found not what?
Not
Not
guilty.
guilty.
Not guilty. Okay,
Yeah.
so what they're basically saying is, look, based on the evidence that was presented, we cannot say you're guilty. They don't say, "Hey, you are innocent." Okay, they don't say that. They just say, "Look, we couldn't find you guilty." I know that's kind of messed up a little bit, way to think about it. I mean, really, you are innocent, I guess. But they say not guilty. All right, so I want to kind of use that terminology to talk about the conclusions that we're going to make in hypothesis testing. All right, so sticking with this example, you can say the person is innocent by saying they're not guilty, or maybe I did do that embezzlement, and they can say I am guilty. All right, so is everybody okay if I go to the next slide for a second?
Yeah.
Are
Yeah.
anybody still typing or writing? Okay. So in hypothesis testing, we make two conclusions, or you can make two conclusions. What I mean, let me rephrase that. There's only one conclusion you make, but there's two options, okay, to pick from, okay? The first thing you can do in hypothesis testing, right, is you can do what's called reject the null hypothesis. Okay? What this means when you reject the null hypothesis is evidence supports the alternative. All right, so evidence supports the alternative hypothesis. So when you reject the null hypothesis, I'm just going to go back for a quick second, okay? What you're saying is this is not right. The defendant is definitely not innocent. And what you're saying is, I hate to say this, but you're kind of like saying, oh, the defendant is guilty. Okay, we're sending him to jail. Matt, you're going to jail. Okay. So evidence supports the alternative hypothesis. Okay. So in this case, what the example was is the defendant is guilty. Okay. So that's the first thing you can do. You can reject the null hypothesis. That's one conclusion you can make. The second thing you can do, we never say we accept the null. Okay, what we say is you fail to reject the null hypothesis. Okay, and when you fail to reject the null hypothesis, what's going on is evidence that you collect does not support the alternative. Okay, so what's going on here is we found the defendant not guilty. All right, which is good in my case, because I don't think I'd survive in jail. Okay, I don't think I'd make it. So when you go to form your conclusions in this class, it's either going to be that you reject the null hypothesis or you fail to reject the null hypothesis. Okay. Give me 1 second. I'm just going to need an extra slide here. Okay, so in our, in statistics, do you guys notice in all these examples, I keep saying the evidence, the evidence, the evidence, right? In statistics, what is the evidence? okay? So let me go back for a second in the slides, okay? This was the claim that we're going to end up testing, okay? I want to check about WCC students and test to see how many hours on average, they spend watching TV. So if I want to test that claim, like, do you think it's reasonable for me to call every single WCC student and ask them how many hours of TV they watch per week? Like, do you think
No.
there's no way I can do that, right? Okay. Like, I don't even have time to cook myself, and my family dinner every night, so how am I going to find time to call every WCC student? So in statistics, it's not reasonable to call everybody in a population. So our evidence that we're going to use is sample data. So what we want to do basically with hypothesis testing, what's really going on here, is you make a claim. Okay. You collect sample data. Okay. And that does your sample data support your claim? Okay, that's really what's going on here. Okay. And that's the procedure we want to talk about, okay, going forward. Is everybody okay if I go to the next slide?
Yes.
Yeah.
Yes.
So what I want to do here is I got two more kind of like introductions or theory to talk about behind hypothesis testing, and then we'll take our break. And then when we come back from our break, we'll just do examples so you can see how this is done. Okay. Because our, if you look back here, so our testing is done by using a sample data. So because our conclusion is based on sample evidence, there is always the possibility, I'm going to say probability instead, actually, probability of making an incorrect conclusion. And what do I mean by an incorrect conclusion? Okay. Looking back here, do sometimes someone who's innocent actually get found guilty?
Yes. Especially here.
Especially here.
Here in this country.
Oh, yes, unfortunately, yeah. I mean, that we could have a whole class about that. Yeah, so sometimes innocent people will go to jail, right? Then that's a bad outcome, okay? And sometimes are people who are guilty of a crime actually get found innocent or not guilty? Like, do some people who commit crimes
Yeah.
actually get yeah, right? And so like those are two incorrect conclusions that you could make, right? Like, so this is what I mean by sometimes there's always a possibility of making an incorrect conclusion. So an incorrect conclusion is like an innocent person goes to jail, or another incorrect conclusion would be that a guilty person does not go to jail, okay? So while there's only two conclusions that we can make, we can reject the null hypothesis or we can fail to reject the null hypothesis. There's actually like 4 outcomes that can happen because you can always make a incorrect conclusion. Okay, let me go through the 4 outcomes, okay? The first one is we reject the null hypothesis when the alternative is true. Okay, so we reject the null. So let me go back. We're rejecting the null. Okay, we're saying, no way, the person is not innocent. Okay, so we're saying they're guilty. All right, when the alternative is true. So we're saying you're guilty when indeed you are guilty. Okay, this is a correct conclusion. Okay, that's a good thing. Let me talk about the other correct conclusion. We fail to reject the null. All right, when the null is true. Okay, so what we're saying is the person is not guilty when indeed they're not guilty. All right, this is another correct conclusion. So whenever we do hypothesis testing in this class, we're always just going to assume we make the correct conclusion. Okay, all right, we're going to say, all right, you know, we didn't make an error. Our sample evidence we collected is good, no problem. All right, but there's always the possibility, always the possibility that you make an error. So let me talk about the error, okay? One is we reject the null. When the null is true. Okay, so we're saying you are guilty when the person is actually not guilty. That would be like saying me going on trial for embezzlement, I didn't do it, and then they send me to jail, okay? Is that a good thing or a bad thing? Sending it, yeah.
Bad thing.
Yeah, all right, we've talked about this. I'm not gonna make it in jail, okay? So this is an incorrect conclusion. This is what's called a type 1 error. Okay, in our hypothesis testing, we want to control for this somehow. So to do this, and you'll see as we go through the problems, okay, we're going to define this variable called alpha. Okay. And alpha is going to be the probability you commit a type 1 error. So we want to make this probability small. Okay, we do not want to send an innocent person to jail. Okay, so alpha is also going to be called, and you'll see this when we do our first examples, the level of significance. And generally in hypothesis testing, there's only going to be 3 levels of significance we'll ever work with. Okay, we'll set it at 1%, we'll set it at 5%, or we'll set it at 10%. Okay, so that's how often we're willing to be wrong, okay, or send an innocent person to jail. 1% of the time, 5% of the time, 10% of the time. No one in the real world really does 10%. These are the most 2 common ones for hypothesis testing. Okay. All right, so sending an innocent person to jail, bad. All right, what's the other error that you can make? Sticking with this criminal justice example.
Not sending a guilty person to jail.
Yeah, that's right. So the 4th outcome is we fail to reject the null. When the alternative is true. Okay, this is an incorrect conclusion. All right, and this is what we call a type 2 error. We're not going to worry about this in this class. Okay, we're only worried about sending an innocent person to jail. Okay, that's the only thing we can control for right now. Okay. All right, so this is important here, this test level of significance. Okay, that'll help us form or make our conclusions, and you'll see that. And then all we're going to do is we're going to reject, or we're going to fail to reject the null. All right, those are the 2 outcomes we're going to make. Is everybody okay if I go to the next slide?
Yeah.
Yep.
Yeah.
So one thing, this is a math class, right? It's statistics. So we have to put a number to something, okay? A number to these hypothesis testing. So we're never gonna write statements like defendant is innocent or defendant is guilty. We're gonna have to put numbers and notation to it. So in our class, there are 3 ways to set up the null H1 and the alternative H0. Okay, so it's always going to be these 3 ways. Okay. The first type of test that we're going to set up is what's called a left-tailed test. Okay. And so when you set up a left-tailed test, you're going to have your null statement and you're going to have your alternative statement. And what a left-tailed test looks like is you're going to have your parameter. And remember, just recall real quick what I mean by parameters. So your parameters for this class are mu or p, okay? So a left-tailed test, you're saying the parameter is equal to some number. I'm just going to use the number sign here. And then the alternative is, wait a second, no way, the parameter is less than that number, okay? So there's keywords that are going to tell you in the word problem here if it's going to be a left-tailed test, okay? So the keywords are going to be things like less than, decreased, gone down, okay? So looking back with how I set up this class, right? I said, you know, I think that WCC students watch, did I say more or less TV than the 20 hours?
You said less.
Okay, so our first example we're gonna do is gonna be this left-tailed test, okay? Left-tailed test. One thing that's important is these 2 numbers are gonna be the exact same numbers, okay? You're not gonna put 2 different numbers here, okay? They're the same thing, always, always, always. And after you see an example, it'll be like, oh, okay, yeah, I got you, man. I know what you're saying. The second type of test is what's called a right-tailed test. Okay. So you have your null and alternative. And the null is always going to be a statement of equality. So it's always going to be, hey, the parameter we're investigating is equal to some number. And the alternative here is going to be something like, wait a second, no way, Matthew. The value of the parameter is actually greater than this number. So the keywords here that you're going to look for in the word problem to tell you that it's a right-tailed test is stuff like greater than, it's increased, or it's gone up. Okay? Those are the type of keywords you're going to look for here. So then the final test that you'll have to pick from is what's called a two-tailed test. And the null statement here is always going to be the parameter is equal to some number. And the alternative is like, wait a second, no way. The parameter is not equal to that number, okay? And the keywords for this type of problem is that you'll see words like, hey, I think it's different, or hey, I think it's changed, Okay, because a number, you can be different by being greater than or less than, and you can change by going up or going down. And so, you ever feel like, I know I've been going on for 45 minutes, but do you think like, does it feel like, oh my God, there's a lot going on here?
Yes.
Mhm.
Absolutely.
Yeah. But I promise you this, okay? I know it seems weird right now, but actually, and I'm stretching, so I'm sorry if I sound like I'm, after you see, I'm going to do 2 examples. Maybe I'll get to 3 in the second half of class. You're going to notice that after you see the first example, you're like, oh, I finally get what Matt's saying. Yes, that makes sense. No problem. I got it. So I promise you, just stick with me, and it's going to make a ton of sense. All right, so let's take our break a little early, if that's okay.
Yes.
All right, so before I go on break, does anybody have any questions? There's stuff they want me to iron out about this. Okay, so let's be back at 9:57 a.m. Okay, so let's take a 10-minute break. All right, and then go check on the wife and kids, make sure they're doing okay. So I'll see you in 10 minutes, everybody. All right, what do you guys, what do you think? Finish up for the day? Everybody still here?
Let's
Yep.
do
You had me scared with
Okay.
your calculator up on your screen though. I thought I missed something.
No, I'm sorry. So, just for full disclosure, it's like sometimes I don't like work every example out before I come to class. Like I'm just like, oh, I'll just do this example. I'll do this example, because I've been teaching for so long. Like, I know this sounds bad, but like I just don't need to work it out ahead of time. And so I just wanted to make sure that I want to give you an example. This is a little bit of a spoiler, I guess, of an example of when we reject or fail to reject the null hypothesis, so that I just wanted to make sure it worked out. But you didn't, you know what? You didn't need to know that. But no, you didn't miss anything. Okay. So what I want to do during the second half of class is I just want to show you how you do hypothesis testing and then get through 2 examples for you. All right, so hypothesis testing, okay, there's 2 types of ways or 2 methods for hypothesis testing. Okay, there's what's called the critical value approach. And then there's what's called the p-value approach. Okay. If you look in our classroom here under week 12, you'll notice that I have a lecture here, the critical value approach, and then I have the p-value approach. So under your week 12 assignment, you're going to use this critical value approach that I talk about in class here, okay? And then when we come back on the 30th, I'm gonna do another example of the p-value approach, and then going forward, okay? And then so going into the final exam and everything, we're gonna use the p-value approach. But just for this week, I wanted to just stick with the critical value approach, all right? I will say this though, if you do the assignment and you get to question 5, okay? And you can type in anything you want. You can do the p-value approach, okay? But the first 4 questions follow the critical value approach to hypothesis testing, okay? So the p-value approach is kind of calculator heavy. And I don't know if you guys notice this in the class, and I know I say this all the time, but like, I'm going to show you how to do it by hand, and then the calculator does it for you a lot easier. You guys notice that?
Yep.
Yeah.
Yeah, and everyone's just like, Matt, why don't you just show us the calculator to begin with? So this week only, your post-class assignment will focus on the critical value approach, and then when we get together in 2 weeks, we'll talk a lot more about this p-value approach. Okay, so this is this lecture. All right, and so there is a 5-step process to hypothesis testing. Okay. I'm just going to write down the steps, and then after you see an example, it'll be a piece of cake. Okay, so step 1. The first thing you have to do is you have to define the parameter, you're investigating, right? And for this example, because we're going to do a hypothesis testing for a mean, it's always going to look something like this. We're going to say let mu equal, and then whatever we're investigating, okay? Also in this step, what you have to do is you have to set up the test, okay? And what I mean by set up the test is you have to pick one of these 3 tests, okay? So it'll either look like you'll either have a left-tailed test. So you'll be mu is equal to some number, and the alternative will be, wait a second, no way, mu is less than that number. And then we're going to have a right-tailed test. You're going to say mu is equal to some number, and you're going to say, hey, wait a second, no way, mu is greater than that number. Or you could have a two-tailed test. Where you say mu is equal to some number. And this one will say mu is not equal to some number. Right. Generally, for as long as I've been teaching, I know it seems weird, but this is generally the hardest step. Okay, like what exactly are we talking about? Investigating and how you set up the test. And then after you do that, after it's set up, the rest of the steps just like super fall into place and are very, very straightforward. Okay. Step 2. You're going to have to select the level of significance. Okay, have you heard me use the term level of significance in the first hour of class?
Yes.
Yeah, the good news is this will always be given to you. So this step, in every single problem, you're going to see something like test at the 0.05 level of significance, something like that. So this will always be given. So this is easy. And it'll end up being something like alpha is equal to 0.05, okay? Or alpha is equal to 0.01, okay? One of those two generally. All right. Is everybody okay if I go to the next slide?
Yes.
Okay. So we're gonna set up the test, select the level of significance. Step 3. Okay. You have to do what's called compute the test statistic. And what this step is you have to analyze the sample data and turn it into a single number. So we want to take like our sample evidence and boil it down to just one number, okay? And our test statistic is denoted as T sub 0, okay? So have we seen the T before in this class?
Yes.
Yes.
Yeah, you did. This is related to a T distribution, okay? So it's just a very, very simple formula, and I'll break it down for you, okay? You're going to take X bar, which is your sample mean. You're going to subtract away mu sub 0, okay? Mu sub 0. So mu sub 0, you notice this subscripted 0 here? You notice in the null hypothesis, you have this subscripted 0. All right, so what mu sub 0 is, it's the assumed population mean. Okay, and where you found this is it's found in the null hypothesis. Okay, you're going to have to divide this by, you're going to take S, which is the sample standard deviation, divided by the square root of n, and n is just the sample size. Okay. Now I want to note this really, this is another common error I see. We're going to do this in our calculator. And when you do this in your calculator, you have to put both the numerator and denominator in parentheses. Okay. Another common error I see is that students don't do that and they get an incorrect test statistic. Okay. All right. So this is legit just going to be a number. Okay. It's going to be a number like 0.5 or 0.2, whatever, or 3.5. It's just going to be a number. Okay. Is everybody, I'll give you a second to copy this. But let me know when I can move on. Just give me like a couple people just say, yeah, you're good, you're good.
So in your calculator, when you do your stats and you get like this S standard deviation and the sigma,
Mhm.
this you're talking about the S?
Yep. Yep.
Okay.
So what you're gonna, yes. So some problems, like let me just say one thing here. Okay. Generally, about half the problems you get, I'm just gonna give it to you. Like you can see here, I give it to you. I just tell you what the standard deviation is. Some of the problems, like on your quiz this week, you'll notice this last one, I do not give it to you. You just have to use your calculator to find the standard deviation. Okay. And if you forgot how to do that, don't worry. There's lecture slides, videos here that show you how to do this. Okay. Like I didn't leave you hung out to dry to do this. Okay. The values at alpha. It's in there somewhere. They're in there to talk about how you do this. Okay. So don't stress about it. All right, is everybody okay if I move on?
Yeah.
Okay, so step 4, after you've got this number, okay, this number we call the test statistic. Step 4, you have to compare it to something. And so step 4, what we do is we find what's called the critical values / critical regions. And here's where it gets a little confusing, okay? There's 3 tests, okay? So there's 3 different types of critical values, 3 different types of critical regions. So for a left-tailed test, okay, if you look back here, this is a t-distribution. Okay, so what you're going to do is you're going to draw a t-distribution, which we know looks just like a normal curve, still centered at 0. And you're going to find this value called minus t of alpha, okay? This right here, minus t of alpha, is your critical value. All right, minus t of alpha, all right, the way you look it up on your test is you need to find first, let me go back to this table. If you remember, you did this on your own in your slides. You need to find this thing called DF. Does anybody remember what DF stood for?
Degrees of freedom.
And do you remember the formula for it?
It's N
N
minus
minus
1.
1.
Yep. So degrees of freedom, N minus 1. And then you needed this thing called upper tail probability, UTP. And that's just equal to alpha. Okay, so whatever your level of significance was. And don't worry, I will do an example for you, no problem. And then you're going to shade to the left here. This red shaded area is what we call the critical region. Okay. Then you're going to have the other thing you could have is a right-tailed test. So again, you're going to draw a t-distribution. It's centered at 0. And it's just going to be t of alpha, but it's going to be on the positive side. Okay, and you're going to shade to the right here. So this is still, again, my critical value. And this is my critical region. All right, again, T of alpha here, degrees of freedom are n minus 1, and the upper tail probability is just alpha. Okay, whatever your level of significance was. So we had left-tailed, right-tailed. Does anybody remember what the final test was?
Two-tailed.
Two-tailed. And a two-tailed test is just a little different. So a two-tailed test has two critical values. It's T of alpha divided by 2 and negative T of alpha divided by 2. So it has two different critical values. And it has two different critical regions. So to find this T of alpha divided by 2, okay, there's only a slight difference. The degrees of freedom are still n minus 1. And the upper tail probability here is just alpha divided by 2. So when you have a two-tailed test, and I'll do a two-tailed test so you can see the subtle difference. When you do the upper tail probability, you just divide it by 2. Okay. So I said it was a 5-step process. So step 5. Your last step is your conclusion. All right, so I said there were two conclusions you can make in this class. You can either reject the null, or what was the other one?
Fail to reject the null.
Okay, so here's how you know. The first one, you reject the null when the test statistic which was that T sub 0 is in a critical region. Okay, so if your test statistic goes past this critical value, T of alpha divided by 2, you reject the null. You can say, you're wrong. Or what you could do is you can fail to reject the null. When the test statistic is not in a critical region. Okay, when it's not in a critical region. And I'll do, and you'll see with the first example, like the differences, I'll do 2 examples, the differences between rejecting or failing to reject the null. Okay. Is everybody okay if I go to the next slide? We'll do our first example.
I'm good.
Okay, so if you remember, I started class, what were we talking about with WCC students?
Hours of TV.
Yep, hours of TV. So let's do that example, okay? And what we're gonna do is we're gonna walk through all these 5 steps, okay? And you'll notice the first example I do is gonna take a little bit of time, okay? Maybe 15, 20 minutes. And that's just because like I'm gonna take it real slow and explain every step. And then when we get to the second example, you'll see that it's just like, once you have this process down, it'll be like boom, 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 we got it. Okay, here we go. Boom, boom, boom. A recent study, this was the hypothesis, a recent hypothesis test we're gonna do. A recent study said that on average, college students watch an average of 20 hours of TV per week. Yeesh, that's a lot. So a professor at WCC thinks the mean hours of TV watched per week by WCC students is less than 20 hours per week. Okay, So first up, just looking at the second sentence here, what are the key words that give away what type of test this is going to be?
Less than?
Yeah.
I got 2 things.
All right, so you're going to be looking for those in the word problem. So this keyword says less than. So what type of test does that tell me it's going to be? Right-tailed, left-tailed, two-tailed?
Left-tailed.
Left-tailed.
Yep. All right, so that's good. Like, you know, you're getting some information right there. Okay, so to test his claim. So I want to test the claim that, you know what, you guys are super busy. You're going to watch less than 20 hours of TV on average. He randomly samples 31 WCC students. So right off the bat, you're given the sample size, 31, all right? And finds the mean of that sample. So you're given X bar to be 18.75. That's awesome. And a standard deviation of 12.25. Okay, that was my sample data right there, right? And then it says test the claim at the 0.05 level of significance. So that right there is your alpha, okay? So you are given enough here to test the claim, okay? So first off, what was my sample mean?
18.75?
Okay, is that less than 20?
Yes.
Okay, so here's the thing you have to worry about with statistics, okay? That's just a sample mean from just 31 students, okay? That is absolutely less than 20. But you got to be careful to definitively say, oh yeah, WCC students watch less than 20 hours. So my sample mean was 18.75. I mean, is that strong enough evidence to conclude about all WCC students? I don't know. All right, so here are the 5 steps here, okay, that we're going to go through. Step 1, you have to set up the test. So the first thing you have to do is you have to define the parameter. And this is the hardest part sometimes for students. Okay? So we're going to be testing a mean about something. So I'm going to let mu be equal to something. All right? What average am I investigating here?
Are you doing the 20?
Okay, well, so hold on. I don't want to put a number to this. I just want to be like, what are we investigating here? So the 20 hours is the average of all college students, right? That's what the problem says.
Mm-hmm.
So what very specific students am I interested in?
Just the WCC students? The
Yes, so
31 of them?
I'm investigating the average number of hours of TV that WCC students watch. So the parameter I'm investigating, mu, I'm going to let mu be equal to the mean hours of TV watched per week by WCC students. Okay, that's what I'm investigating here. I'm trying to test something about this parameter, the mean watched by WCC students. Now I need to set up the test. So you need to set 2 statements, okay? H0 and H1. So it's a left-tailed test. So it's going to be mu is equal to some number, and we're going to say, no way, mu has to be less than equal to some number, okay? So the null hypothesis was your base assumption. So you have to start with some assumption, okay? And what did the study say that college students on average watch per TV per week?
20 hours.
So here's the thing. You have to start with the assumption that WCC students are just like every other college student, okay? And they watch 20 hours per week. Okay, that's our starting assumption. But what were we all kind of like, wait, no way, that seems high, okay? So what we want to do is we want to show evidence that no way, the average students watch less than 20 hours per week, okay? What we don't want to say is that, oh, they watch 18.75. No. We just want to say, no, wait, okay, slow down. WCC students watch less than 20 hours of TV per week. Thank you very much, okay? That's what we want to test. All right, this is the hardest thing, honestly, right here. Like once you figure out how this is set up, like the rest just kind of like falls into place very, very easily. Okay, step 2. Do I give you the level of significance?
Yes.
Yep. It's right here. Boom. Okay, so I want to take all this sample data up here, boom, and boil it down to just one number. So that's our test statistic. Okay, that's T sub 0. And there's just a formula for this. It's just X bar minus mu sub 0 divided by S over the square root of N. So it's just 4 things, okay? And if you look here, they're all given to you. So X bar is 18.75. What is the value of mu sub 0?
20.
Yep, that's right. It comes right here from the null. Boom, 20. S is 12.25. And how many students did I sample?
31.
31. All right, everybody grab their trusty calculator, okay? I'll actually do it in the TI-83. I think most students have the TI-83. All right, what did I say is important? That you have to put both the top and bottom in.
Parentheses.
So 18.75 minus 20, close the parentheses. Now divide, whoosh, start a new set of parentheses, 12.25 divided by the square root of 31. Now here's where it's a little weird on this calculator. You have to close the square root parentheses, and then you have to close this parentheses right up there. How many people got that number right there?
Yep.
Yep.
Okay, so for these test statistics, let's go out 3 decimal places. Or 4, it doesn't matter. So it's minus 0.568. Okay, so this is just a number. Okay, I took this problem and I boiled it down to one number, right here. That's it. Okay. So the next thing I need to do is I need to find the critical value or the critical region. I'm actually gonna do it over here so I have a little bit of room. So step 4, you're gonna draw this t distribution. Centered at 0. And I gotta find this minus t of alpha. Okay, and then it's a left-tailed test, so the critical region is gonna be this red area shaded to the left. Okay, to find this, okay, first thing you need is degrees of freedom, DF. All right, can anybody tell me what the degrees of freedom are for this problem?
30.
Yep, it's n minus 1, so it's 31 minus 1 is 30. And the upper tail probability, I just said is alpha. Okay, do I give you alpha?
Yes.
Okay, it's 0.05. So we're just gonna grab this t table right here. And here's what you do. You find the upper tail probability, 0.05, boom, right there. Degrees of freedom, you go down to 30, boom, right here, okay? And you look where they intersect. What number do you see on the table there?
1.697.
Did you notice how it's positive here? Okay, all the t-table problems are positive. But do you notice over here it's negative? So all you're gonna do is take the positive number you just got and make it negative. 1.697. 97. Okay. So now you need to form a conclusion here. All right. And the way I do this with the critical value approach is I take this number here, okay, and I treat this as a number line, okay? So here's 0, here's negative 1.697. Negative 0.568 has got to be like right here. Okay. Is it inside or outside the critical region?
Outside.
It's outside. Okay. So it's not in the critical region. Okay. So when it's not in the critical region, all right, are we going to reject or fail to reject the null?
Fail.
Say it louder.
Fail.
We're
Fail.
going to fail to reject the null. Yeah. So our conclusion here is this. We fail to reject the null hypothesis. So what this means is the evidence we collected does not support the alternative. So we cannot say that WCC students watch less than 20 hours. Watch less than 20 hours on average. Ha! So you guys watch just as much TV as everybody else. Sorry. So now you saw me do one example. What do you think? Crazy, not crazy?
Not that bad.
I know it's just the first example, but like, yeah, if you just follow this 5-step process, it's never that bad. What do you guys think? Do one more example?
Sure.
All right, does anybody need? Definitely. Absolutely. Okay. Is everybody okay if I go to the next slide?
Yeah.
Okay. So I'm just going to set this example up. I'm going to type it out, okay? So according to the website salary.com, have you guys, I don't know if you've ever heard of this. The mean earnings of family doctors. So these are just like family care doctors, like a primary care physician. All right, so on average, family doctors earn, I'm just going to round this a little bit, $178,000 per year. Okay, that's their average. All right, is that pretty good salary?
Yes.
Yeah, it's okay. You know, but you know, they have to go to med school. They have bills. You know, most doctors make significantly more. Family doctors and pediatricians are actually the lowest paid doctors for some reason. Okay. I don't know why, because my pediatrician has to deal with me and my crazy phone calls all the time. So I think she's severely undercompensated. Okay. So this is thank you for that laugh. Okay. You know, my pediatrician gets calls like, oh my God, my son threw up. Is that normal? Yes. Stop calling me at 2 a.m.
That's too much.
That's a joke. That's definitely a joke. But we have called, you know, with a lot of silly questions. Okay, so here's the thing. This is the mean of all family doctors across the entire country, okay? So this is the question I have. Do you think family doctors in New York City make a different amount on average? What do you think? Do you think the mean in New York City is different than that for some reason?
Yes.
Yes.
Probably, right?
Probably higher.
It's probably higher, okay? So here's the thing. I agree that it's probably higher, but just for this problem, okay, just for this problem, I want to test to see if it's the mean is different, okay? So what's the key word in there that tells me what type of test this is?
Different, two-sided, right?
Yes, so the key word here is different. And so that tells me it's going to be a two-tailed test. Okay. So here's what we want to do. We want to test to see if the mean family doctor salary in New York City is different. Okay. Whoosh, different. So to do this, what we need to do is we need to collect data. So, okay, so you sample 41 family doctors in the best city in the world. I think we can agree on that, correct? In New York
Yeah.
City?
Yeah.
Absolutely. Okay. Just as a sidebar, it's definitely the best city in the world. I've been lucky to travel in my life a lot before my kid came in COVID, and there's no city like New York. Just gonna say it. All right, so you sample 41 family doctors in New York City and find the mean to be $201,000 a year. Okay, that's their mean salary with a standard deviation of $42,000. Okay. Let's conduct the test. At the 0.05 level of significance. Okay, sometimes it helps to do this, to just write out what you're given, okay, just so you know ahead of time, okay. How many doctors did I sample?
41.
Mm-hmm. What was the average salary of those doctors?
201,000.
Yeah, you got to be careful with that one. And then the standard deviation was?
42,000.
Yep. Okay. Do I give you alpha?
Yes,
Yes,
0.05.
Yep. Okay. So that's what you're given. So this is just a tip, okay? Sometimes students have a hard time setting up the null and alternative hypothesis, okay? So to figure out what goes in the null and alternative hypothesis, like what's the only number that I haven't put in what's given?
Mu?
Yeah, do you see this, the 178,000? Do you notice how that's not the sample mean? So that's the tip or hint that this is mu sub 0, okay? That's the tip, okay? The remaining number that's not given. Is everybody okay if I go to the next slide?
Yes.
Yeah.
Okay. All right. So to go through the process, the 5-step process, let's just do it. Step 1. The first thing you need to do is you need to define the parameter. Okay, so that's let mu equal to something. So I'm going to go back for a second. We know what the mean family doctor is salary across the United States, okay? What mean are we specifically looking at? In what location?
The New York City doctors.
That's it. Yep. We're just looking at the mean salary, mean family doctor salary in New York City. So mu is going to be the mean family doctor salary in New York City. Okay, now what we need to do is set up the tests. Okay, what type of test was this again?
Two-tailed.
So it's mu is equal to some number, and we're saying, wait a second, no way, the average has to be different. Okay, so we have to start with some base assumption. And we're gonna assume that doctors in New York City make the same average as everybody else. We're assuming they make 178,000 on average. And what, we want to test to be like, no way, come on, they gotta make more than that, stop it. Okay. Step 2 now. You're going to select the level of significance. All right. Did I give that to you for this problem?
Yes.
Yes.
It's 0.05 right there. Okay. Now you need to boil this down to one number. Okay. So that's step 3. All right. Is your test statistic. So that's just x bar minus mu sub 0 over s divided by the square root of n. What did I say the average teacher salary was in New York City, the x bar?
201,000.
1,000.
Mm-hmm. Mu sub 0 comes from right here, so I'm going to subtract away 178,000. The standard deviation was 42,000. And how many doctors did I talk to again?
41.
All right. Grab that trusty calculator. It's always worth it to practice this as you see me do it. So on the top gets parentheses. Divide by, bottom gets to parentheses. Let's see if I did it right. How many people got that number right there?
Yes.
Got that.
Okay, so it's 3.506. Okay, so now I've boiled this down to a single number. So what I have to do is compare it to something. Okay, so this is a two-tailed test. So I have two critical values. I have t of alpha divided by 2, and I have minus t of alpha divided by 2. And I'm going to shade the critical region to the right and critical region to the left. You get sound effects today. Hope that's okay. Okay, so to find this t of alpha divided by 2, you need degrees of freedom. Okay, that's still n minus 1. So that's 41 minus 1, that's 40. And now for a two-tailed test, this is important. What did I say my upper tail probability is? It's no longer alpha, it's what?
Alpha divided by 2.
Alpha divided by 2. So it's 0.05 divided by 2, which gets you 0.025. So you have to be very careful about that, okay? So now when you go to here, you're going to have to go your upper tail probability. You're going to have to find 0.025, degrees of freedom 40. Do you all see 2.021?
Yep.
Yes.
Okay. So that means this one here is 2.021?
Yes.
Sorry, I've only had half a pot of coffee. I'm not all there yet. What do you think this one is with the negative sign then?
Negative 2.021.
Okay. So now step 5. This is your conclusion. So treat this as a number line. Here's 0, here's 2.021. Is this number over here somewhere?
Yes.
Okay, so it's in the critical region. See how it's in the shaded area?
Yeah.
So what does that mean?
We reject it.
We reject the null. So basically what's going on when you reject the null, you're saying, no way, that's not right. This is correct, okay? So evidence supports the alternative. And you have to be careful here, okay? We're testing to see that it's different, okay? We didn't say that it's gone up, okay? That's not how we set up our test. It probably has, but that's not how we set up our test. So evidence supports the alternative, and we can say the mean salary of New York City family doctors is different than this 178,000. Okay, it does look like they make more, but we set it up as a two-tailed test. What'd you think?
Yeah.
So so I'm gonna, before we leave, let me just, was this the class that said that they want me to save it as a PDF? I forgot. When people load up my PowerPoint, so they sometimes have a hard time seeing my write-up.
I don't know about that. I have a question though about the actual math.
Yeah, 1 second. What was your question?
Is UTP always alpha over 2?
Only for a two-tailed test. So if you look back here,
Okay.
it was a right-tailed or left-tailed test. UTP is just alpha. You only do alpha divided by 2 when it's a two-tailed test.
Got it. Thanks.
Okay, so going back to the classroom here. Lectures 1 and lecture 2 are just a different, very condensed version of the lectures I just gave, okay? I'll also post the recording. It'll be up in about a couple hours. I'll shoot you an email, let you know when that is. Lecture number 3 is a different approach to hypothesis testing. It's called the p-value approach, okay? I'm gonna be honest with you. I actually think the p-value approach is easier, okay? Because it relies heavily on your calculator. So your calculator does all this work for you, okay, which is nice, right? We like that. So please watch this video here, okay? I don't even know how long it is. It's 15 minutes that walk you through 2 examples, okay? And then there's also lecture number 4. I do a lecture that shows you how to use this website here, just in case you want a different way to do this. And then your assignment here, you only have 1 attempt. Okay, so as soon as you submit it, you're done. So it's none of the 2 attempt stuff. Okay, so that's not due until Monday the 30th, but I encourage you to just get it out of the way now and enjoy your Thanksgiving break. And there's no class next Tuesday. All right.
Professor, when is the final? I'm sorry.
Yeah, no problem. So here's the remaining classes. So we're going to come back on the 1st. Okay, I'm going to do hypothesis testing for proportions. The 8th, we're going to have the entire class to do a review for the final exam.
Okay.
And then the final exam is going to be on the 15th.
Awesome.
Okay, the final exam is going to happen during class. And basically what's going to happen is you're going to take a much longer extended version of the homework, like during the 2-hour class period.
Is it gonna be like the last time where we have to write it, or is it gonna be like this assignment, for example?
It's going to be a mix of both. So some of the problems will be like this, like the homework question here, where you have multiple choice, or there'll actually be a fill in the blank question. And then there'll be some problems that are like this.
Right. It's not gonna be a document where
It's not going to be a document, no.
Okay.
Hey, Professor, I have a question.
Sure.
So you said that the week 12 assignment usually it bases itself around the critical value approach. So should we watch the p-value approach after we complete it, or should we watch it before just to help us out?
Here's what I would do. Questions 1, 2, 3, and 4 are the same problem. Okay. And they look at the critical value approach. Like it says, what is the test statistic? What is the critical value? Question number 5, you can do either way, the p-value approach or the critical value approach, okay? So if you just wanted to get the critical value, just get it out of the way, do that, and then watch the p-value approach, or you can watch p-value approach first. So when we come together in 2 weeks, I'm going to do an example or two of the p-value approach. And then when we do hypothesis testing for proportions, I'm only going to use the p-value approach.
Okay, thank you.
Yeah. Everybody, I wish you all a happy and safe Thanksgiving, and I will see you in 2 weeks.
Thank you.
Thank you.
Goodbye, everybody.
Thank you.
Have a
Thank
good
you.
Thanksgiving.
You all as well.
Yeah, happy Thanksgiving.
Yep. Thanks, everybody.